Welcome to the special session on development of correlations using Microsoft Excel. This session will be helpful for experiment number 2 of HVAC&R, that is performance analysis of chilled water air conditioning system using a numerical method, that is Newton-Raphson method. This particular session is also useful for the students or researchers who are working on some experimental work and wanted to develop a correlation between output parameter and input parameter using regression analysis. The learning outcome of these sessions are mainly you will be able to develop equation or correlation having more than 2 input variables using a multiple regression analysis. Then validation of that equation or correlation using the standard data or experimental data. The important steps of developing correlations are preparation of table in the Excel with the help of dependent and independent variables. Then in most of the Excel sheets, the data analysis tab is not visible there on the Excel sheets, or in fact, it is not activated. So how to activate that data analysis in Excel, that we will see. Then how to apply regression analysis on the table or the data. So in this particular session, we'll see how to develop a equation or correlation for compressor from the given table or the given data. So how to develop a compressor correlation from data, that we will see. Then validation of that correlation from the table value, and in order to obtain the accuracy of the correlation. Now if the compressor, this is a typical compressor catalog available from Google or this any compressor manufacturers having such kind of catalogs. So these are different model numbers and their performance parameters for various operating parameters. So as far as the compressor concerned, the operating parameters are evaporating temperature. So these are the evaporating temperatures. So 12.5 and it up to minus 30 degrees Celsius. This is a cooling capacity for these evaporating temperatures for the same condensing temperature, that is 30 degrees Celsius. So these are the condensing temperatures. And you can have the values of cooling capacity and HR, that is called as a condenser capacity in kilowatt. So the difference gives us work input to the compressor. So these are the values for refrigerating capacity as well as condensing capacity for various evaporating temperature and condensing temperature. So as a part of experiment number 2, you have to, this compressor catalogs are provided here, and the model to be used is also given in the problem statement. So you have to, based on your model, you have to select particular table values. So for example, if your model is 4 into 2 cc 3.2 y, now you have to select these table values, and now these values you have to write, because these are the output parameters and input parameters are also there. So you have to write all these values in Excel sheet in the appropriate format. So this is cooling capacity, compressor power. So TL, that is evaporating temperature, condensing temperature, then cooling capacity in watt, in fact here. Similarly, the compressor power data is also extracted and written in appropriate format. That is, these are the input parameters and this is the output parameter, that is work. Now here we have to develop the relation between QL, because QL also varies with TL and TH. So in order to develop the equation between QL and TLTH, we have to apply the regression analysis in the Excel sheet. So you have to go in data. Now check whether the data analysis tab is visible here. If it is not visible, that means it is not activated. So for example, in this particular sheet, here the data analysis is visible. But if it is not visible, then you have to go to file section, then go to options. In the options, you have to add in the this particular facility, or you can click on add in tab. So where there is analysis tool pack, so this you have to click this. You have to select this analysis tool pack, and the manage Excel add-in. You have to add this particular tool pack in Excel. So click on go. Now these are the add-in available in your Excel. This is Microsoft 2010 or Excel 2010. So you can click on analysis tab, or maybe you can click on analysis tool pack VBA also. Click on OK. Okay. So here you can see the data analysis is available. Now you have to select the data, including the label values. So the entire then you can click on data analysis here. So in the data analysis, you scroll down and select the regression. So regression, if you select, I have to select the input variables. So input Y range means that is actually an output variable. So output in, for example, cooling capacity is the output. So select entire range of output. Then input X range means the independent variables or input data in our case. So select here and select the range of all input variables. Now in this case, the input variables are TLTH. So including label also you can select. Then you have, if you have selected label, then click on label. If you are not selected the label, then not necessary to click on label. The confidence level, you have to make it up to 95%. Then where the output data is to be extracted, so output range. So just below this data, you can select output range. So this is output range. So here we have selected just 2 rows below the input data, the data table. So in this way, we have selected output variable, that is input Y range. Y is obviously our output variable. X range is obviously the input variables, and output data range we have selected there. Then click on OK, where the Excel sheet will perform a data for summary output for regression analysis for you. So this is a statistics of regression analysis. Now these are the coefficients obtained for this. This is interception, that is constant value. X variable in, because I have not selected the label. So X variable 1, that is our TL value. This is a coefficient of TL. This is coefficient of TH. Then we can write this, suppose in order to this is our table, that is TL, TH, QL. And based on these values, suppose these are the coefficients. So based on these coefficients, where you can check the R square value also, it is greater than 0.95 adjusted. So you can write the expression for QL. So QL is equal to The coefficient of TL is 1060.89 TL minus coefficient of TH is minus 370.55 TH, and the interception, that is a constant, is a plus value. So similarly, we can develop equation of compressor power. So this equation is also developed based on these coefficients. So these are the three coefficients. One is constant. 150 is the coefficient of TL. 90 is the coefficient of TH. So this is equation of work. This is equation of QL in terms of TL, TH. Now, in order to check the validity of this equation, so these are the calculated values. So based on this equation and choosing TL and TH values, we can calculate the QL values. And these are the deviation of calculated values with the table values. So the average deviation is only minus 5%, where the maximum deviation is 18%, and that too at the end results. So that is at whether it maybe at the initial values and or the final values. So most of the times this correlation gives approximately values, uh, correct values with plus minus 10% variation. So average variation is minus 5%. Similarly, you can check the accuracy of work equation. So there also the maximum is 30%, but again it is at the end only. But more or less the average variation is only 0.7%. So that indicates these equations gives quite accurate values of QL and W based on TLTH values. So this is a correlation developed. So the same uh, steps you can apply on experimental data in order to develop the relation between output variable and input variable for any experimental data. So this is the equation developed, because these equations are required for numerical analysis in experiment number 2. So that's why I have taken this example. But most of the experimental studies, you can have this input variables, and also the output variables are also measured. So you can apply this regression analysis in order to develop the equation with or relation between output variable and input variable. And also you can check its accuracy level by calculating the values of output variables with the help of input variable and compare this value with the measured values, or maybe in this case in the table values or standard values. So accuracy level can be checked. So that's it. I hope this particular session is definitely helpful for you, uh, not only for this particular experiment, but also during your project work also, wherever you come across such kind of data, this particular correlation or this particular session is definitely useful. Thank you very much.